thanks everyone for joining me today. I really appreciate your time. I know that there's many of you and it's a lot of time to take. So thank you so much for that. In today's session, what I wanted to do is to talk a little bit about how to think in frameworks and how data engineers and anyone who's working with data really can accelerate their work and make the work a lot more efficient by generating some frameworks that will do a lot of the work and the heavy lifting for them. So in this session, I'll do a live coding demo, and I'll write some code. I'll demonstrate some of these ideas. And mostly I'm trying to cover some of the basic concepts here more than the code itself. And if there's anything you really want to take out of this session is really the concepts. I will oversimplify some of these ideas because it's just really not easy squeezing everything into just a 1 hour session. And I'll try to leave some time in the end for your questions. Obviously, if anyone has any other questions, feel free to reach out to me afterwards or on LinkedIn, on Facebook, whatever, whatever communication tools you prefer to use. I'll try to respond as quickly as I can. There are many ways these ideas can be expanded, so really be creative. Take what I'm showing here as a starting point, not as the ultimate goal, because there's a lot of things you can do. And at Facebook, we do use some of these ideas. I've been doing these things before Facebook, and at Facebook, we have a lot of these things, but just on steroids, really. And so you can be super creative in what you do with this. I would like to apologize because I did have to make some assumptions on prior knowledge here. I know that some of the things I will be talking about may not be clear to everyone, but hopefully you can follow. And every time I think I'm talking about something that some people may not be aware of, I'll just highlight that so you can write it down and you can follow up later if you want to, and you can search the documentation and all. And the last point here really is, please don't worry about things like performance, code quality, etc. Just really focus on the key concepts here, because this is what matters. I'll probably be doing some very nasty things as I go in terms of code, and there are some things that can be optimized and work a lot nicer and cleaner, but I'm just trying to show an idea or concept here. So with that context in mind, let's just jump right to it. So for the purpose of this session, let's just assume that we work in a money transfer company. You can think of PayPal, for example, or TransferWise or MoneyGram or whatever money transfer company you want. And in a typical money transfer company, you might have a fact table in your warehouse that looks like that, which is fact payment, and you might have all the transactions, and every transaction is basically a money transfer or transition money between a sender and a receiver. So we have the sender ID and receiver ID. It's also usually typically between different countries. So we'll have a from country to country dimension. We'll have the amount of money that's being transferred and obviously a transaction date. Now, if you're a data engineer or data scientist or anyone working in this kind of environment, you might start creating some aggregation tables on top of that. So one aggregation table might look like that: create table, sender, payments, aggregation as, select sender ID from, and some amount USD as total amount from fact payment, group by sender ID. So that could potentially be one aggregation table that you might create. Maybe you also want to create another aggregation table by country, because it really matters, how much people transfer in the context of a country. So we might have a country payments aggregation table as set from country and some amount USD as total amount, and fact payment group by from country. And obviously we'll have a daily payments aggregation, because looking at how much money is being transferred by date is really an important thing in that context. And I don't know if you can start seeing it already, group by transaction date, but there is some sort of a pattern or template emerging here, and I'll try to show you that. All these simple aggregations, they actually look the same and they follow the same structure, which is basically create table, destination table, as select some sort of dimension, and then we have a metric definition from source table, group by the same dimension, right? And metric definition is typically going to be a simple aggregation metric. So that will be maybe an aggregate function over some expression as some alias. So at the first stage, what I would like to try and do is see if I can templatize these queries, and we'll just take one of them as a starting point and see if we can create that template and start wrapping it up and create some sort of a framework around it. So before I start, I'm just going to create a quick test here, just so we have something to work with and compare to. And what I'll do is I'll just literally print this thing here. And maybe I'll just line break here, expected output, line break, line break, line break, I'm just gonna try and make it nice. And then one more of these, line break, sorry. And line break, this thing is just going to be maybe 50 dashes. Okay, and I'll just execute this code right now on my terminal. And what you can see here is this is the output that I'm expecting to get. So what I'm going to do now is I'm going to create a new class or a new type and call it simple aggregation. And simple aggregation, let's just define it. First of all, my init function for now, let's just keep it empty. And we'll also have another function called getQuery, which in our case will just return literally what I just had here. And if I go ahead and create an instance of simple aggregation, so let's say that sender payments aggregation equals to simple aggregation. So I'm creating a new instance of this class. And what I'm going to do is just print sender payments aggregation.getQuery. And let's see what that looks like. Cool. So now my basic, my simple aggregation function is literally just returning a static string. Let me just do this, which is not entirely what we wanted to do, but that's, I guess, maybe the first step to get there. So now I'll replace this string with the template that we defined. So I'll just take this template, and instead of having a fixed string, I'm going to use that template. That's all I'm doing. And if I execute this code again, you see that I'm not really getting my expected output anymore. But the good news is all of these can be used as tokens for the format string function to basically plant the right values in the right places. And I can basically get back to the query that I had up here. And so the problem is, it's not a problem, but the next thing I need to do to be able to format it and give it all the parameters that I want, like dimension equals something and metric definitions equals something else, is I need to get those parameters from somewhere when I create this simple aggregation. So obviously there's two ways I can probably go about it. One is I can literally define all of them here. So destination table, dimension, metrics definitions, etc. And the init function will expect all of these values, and then I can just use them in the format function. I'll just store them and use them. But that's probably not the nicest way to do it, because I'm going to have a lot of these. And if you keep going with this idea of like, you keep expanding your framework and keep enhancing and building it, then you will have many, many of these. So the next thing, the other thing I can do is just use KWArgs. And if you don't know what KWArgs is and KCArgs, I'm encouraging you to look at the Python documentation and learn that, because it's a very nice and useful concept. And what KWArgs basically means is that this function will now get an unlimited number of values or number of parameters, and it will pack all of them into one dictionary. So I can use that dictionary later whenever I want, but I'm not limiting myself to the number of parameters I'm getting, or I don't need to necessarily specify all of them up front. And to demonstrate that, what I'll do now is when I create my simple aggregation, I'll state that the destination table equals sender payments aggregation, and my dimension equals sender ID, and source table equals fact payment, and my what am I looking for? Metric definitions equals sum amount USD as total amount. And let's look at what I'll just go ahead and print KWArgs now. Let me just remove some lines so maybe you can see some of it. I'll just go ahead and just print KWArgs for you so you can see what that looks like and execute the code. So you can see that I'm really passing these as, forget about this error, I'm really passing these as separate parameters to the function, but KWArgs will basically package all of them into one dictionary. What I'll do now is I'll go ahead and just store this dictionary somewhere. So self.underQuery parameters equals KWArgs. So now, every time I create an instance of a simple aggregation, I'll get a set of parameters and I'm just going to store them. And now I just need to find a way of passing these to the format function. Again, I could go ahead and do dimension equals self query parameters dimension, etc., and start doing these wiring. Or the easiest thing to do is to do the same trick I did with KWArgs and now take my query parameters dictionary and unpack it into separate values. And the way it's going to work is basically just like that, self.underQuery parameters. And if I do that, you can see that I just basically did all the right wiring. So I'm passing the parameters, I'm storing them in a dictionary, I have a template, and when I call the get query function, I will basically take all the tokens, replace them with the right values, and I get the same expected output, which is awesome. The next step, this is really the beginning, and that's how you start. Now, I think that this is great, but there's one thing I really don't like about it, and it's the metric definitions part. And the reason I don't like this metric definition part is because it's just a string. And this is not robust enough. And probably if you will want to go ahead and play with it, you will want to expand it with new types of metrics. Some of them will be more complex, some of them will be more descriptive. So what I'll do now is I'll go ahead and define another type of simple aggregation metric. And I'll try to create a type for a metric. So it's not just a string, it's something richer and bigger, and it has some more structure behind it. And the way it will be defined is I'll have my init function and I'll have my get metric definition function, which will just return something. Let me get back to it. Now, if we look at this example here, this metric definition, every simple aggregation metric will consist of 3 parts. Sorry. Every simple aggregation metric will consist of three parts. The first one is some sort of a function that I'm running. In my case, it's going to be sum. Then some sort of an expression over which I'm running this function. And finally, an alias, right? And I can go ahead and just store these values. So function equals function, and self under expression equals expression, and self under alias equals alias. So now I got all of them. And if I want to reconstruct this from those values, what I can very simply do is I can say that I have my function over my expression. So that's my template really, as alias. And I'll format this and I'll say that function equals self under function and expression equals self under expression and alias equals self under alias. And I'll just show one example of this before I start wiring or planting this into the table itself or the query itself. I'll just separately create a new metric, m equals simple aggregation metric of sum amount USD, and we'll call it total amount. And let's print get metric definition. So let's go ahead and run this now and see what happens. So you can see that now I've been able to reproduce exactly the same output or the same metric definition, but the way I construct it is using a nicer structure. And what I can do here is, let me get rid of that. I can just start passing, because we know that we're going to have probably more than one metric in every aggregation table like that. So I can change that to a list and I can start passing those values. And simple aggregation metric of sum amount USD, total amount, and maybe I can just create, for the sake of demonstration, another one, which is going to be count star. Oh, sorry, and we'll call it num transactions. So now I have two metrics defined. And if I go ahead and execute this right now, you will see that I kind of broke my code a little bit, because instead of seeing those metrics, now I see the representation of those classes. So I do have a function to get the metric string itself. And what I need to do is now iterate over that list and basically call that function for each element so I can get all the strings. So let's go ahead and do it. And the way I'm going to do it is using a list comprehension. Again, this is another place where I'm assuming a little bit of prior knowledge. If you don't know what a list comprehension is, or list comprehension or dictionary comprehension, go ahead and read the documentations. These are some of the most powerful tools in Python to basically construct lists and dictionaries on the fly. They can save you a lot of time and they're very nice to work with. The way a list comprehension work is basically what I would like to do is I would like to iterate now over for metric in self query parameters metric definitions. I want to go over them one by one, right? And what I want to do is for every metric, what I would like to do is basically execute the get metric definition function and create a list of that. And in a nutshell, that's how a list comprehension works. So this is a list comprehension that will do exactly what I just said, iterate over this array. And for every value, it will just call the get metric definition function and will create an array of what I get there. And I can store this list somewhere. Let's call it self.metric definitions string. Sorry. Self under query parameters metric definition strings. And I'll just change it here in the template as well. Okay, so I'm not using the original metric definitions, which is literally just uh, a list of class instances, but I'm actually using the strings. And let's go ahead and execute this right now. So you see that I have a list of all those strings. And the next thing I can do is just concatenate all of them, like basically convert that list into a one big long string concatenated by commas. And the way I can do it is using the join function, the string join function in Python. So I'm going to use a comma as my delimiter, and I'll do it over this list. So now I converted all of that thing into one big string. And if I want it to look nice and very formatted, what I can also do is concatenate it by a comma, new line, and a few spaces. So that should basically give me a very nice, clean code. And I can add as many metric definitions as I want. Now, the next thing I don't like about this is that I need to work very hard to define just one very simple metric like sum over amount USD. It's not actually saving me any time, right? So what I can start doing now, I can start playing with the idea of defining more descriptive types of metrics. For example, I can create a new type of metric called total. And total is going to be of a type of simple aggregation metric. And the way I'll initialize this total function, basically when I want to do a total over something, I just need one expression, and that's it. And I'll initialize it exactly in the same way that I initialize a simple metric, simple aggregation metrics. I'm assuming that people here understand how object-oriented programming in Python works and inheritance and all of that. But if you don't, then I think you may want to go back to the documentation and learn a little bit about that. And what I'm basically doing is I'm creating a new type that's inheriting from simple aggregation metric. I'm going to initialize it in a slightly different way. So when I do a total, then my function is always going to be sum. My expression is whatever expression I give it in that, in my example, amount USD. And the alias, I can say that it always follows a specific template, which is total under, and then whatever the expression was. Come on. And then I don't need to define, obviously, the get metric definition function because I'm inheriting that from aggregation metric. That's the beauty of it. So it will work exactly in the same way. So now I can go ahead and create another metric here, which is total of amount USD. And that's going to work exactly in the same way. Let's take a quick look at that. So now you can see that I have my total here defined, and it works perfectly. It follows a nice structure. And if I want to total something else, if I had another column, let's say, number of transaction, lifetime transactions to date, whatever, then it will basically give me the total lifetime transactions to date by sender. Well, I'm just showing the idea. Now, this is still, again, not saving me tons of time, right? But what I can do now is start implementing nice design patterns or things that I do very regularly. For example, if we group by sender, one of the very common things that we may want to do is to see how many transactions they've had in the last X number of days, right? And I can basically create that. Let's call it total last X days. So that can be another type of function. And the way this one will work is we'll take an expression, we'll take a date column and the number of days. And again, the function is sum. always because it's a total. The expression is going to be different. It's going to be case when date column is greater or equal to number of days, then expression, expression else 0 end. So that's my pattern. I'll format it. And now I'll just have to say that date column equals my date column, number of days equals number of days, and expression equals expression. And that's it. And so if I want to now create a total number of days type of metric, let's see what that might look like. Total last X days amount USD over transaction date. And let's take the last 7 days. Oh, and one more thing I probably want to change is the name of the metric, the alias. So in my case, it's going to be total amount USD and then number of days D, to tell people that this is the total of the last 7 days, for example. And I'll show you that in a second. So num days. And let's go ahead and execute the code. And you can see that I'm just creating this really nice, and that's a very common pattern that you would have in your warehouse and with your aggregation tables. Now, this is great, but it's actually very common to have many of those last X days type of metrics, right? So maybe I'll have one for the last day, last 7 days, last 14 days, last 30 days, 60 days, 90 days, 180 days. So I have many of those, and I'll just execute that and see what that might look like. So you see that I have a little bit of a repetition here, and that's probably not the most effective way of doing it. So what I can do is I can probably now create a new type of metric, which is going to be, and this is where things might get a little bit nasty. I'll caveat and say don't worry too much about it, because now there are nicer ways of designing this and making it easier to follow. But I'll basically create a multi total last X days type of function, type of class, which will basically be initialized in a very similar way. I have my expression, date columns, and the number of days is going to be a list of number of days. And what I'll do is I'll just, again, create, what I want to do is to create many instances of total number of days for that list. And I'll show you what that would look like in a second. Let's do another list comprehension. So in my case, I'm going to iterate over for num days in num days list. So I'm basically going to get a list of number of days, 1, 7, 14, 30, 60, 90, 180. I'll iterate over that. For each one of them, I'll just go ahead and create a total last X days metric with the same expression, the same date column, and the number of days, the specific number of days I'm talking about here. And what I can do is self.metrics equals to that list comprehension. So I'm basically just creating a list of total last X number of days. And def get metric definition self will just return a list of metrics. And let's see, I'll just show you what that would look like, and then we'll get it back to working state. So first of all, let me just create one and print it. So last X days amount USD, transaction date, and 1, 7, 14, 30, 60, 90, 180. And print get metric definition. And I'll execute that. So as I said, that will create a list of total last X days objects, and it will just create several of them, one for every number of days I specified. So I can now go ahead and put it here, because essentially that's one of the types of metrics that I want to have. And now this is basically going to break my code, because up until now, each one of those metrics was just one simple aggregation metric element. And now I'm retaining a list of simple aggregation metrics. So it's basically not the same anymore. So I'll just show you how it breaks the code. And it will say, oh, comma. So now in my list comprehension in line 139, basically when I iterate over that, on my metric definition, I'm expecting to see a string and I'm seeing a list. So I need to overcome that little hurdle, and that's going to be a little bit nasty. There's not, now is the point where maybe it makes sense to refactor a little bit and make it more seamless. But just to do a quick workaround, what I'm going to do is I'm going to create a new list of metrics, and I'll basically iterate over the metric definitions that I have. So I'll do what I was meant to do anyway. And then the metric definition equals to metric.get metric definition. Now, in this case, there's two possible scenarios, right? One is that I get a string, and the other one is that I get a list. If this is a simple aggregation metric, calling get metric definition will just give me a string. And otherwise, I'm going to get a list of simple aggregation metrics. So what I'll do is I'll basically check if the metric definition I got, the result that I just got, sorry, if type of that is a list, then what I need to do is all metrics extend all metrics, extend metric definition. Otherwise, I'll just all metrics append that very same metric. This is a little bit nasty and cumbersome, so I'll just explain what I did here very quickly. I'll just print all metrics now. So I'm printing this, and you can see that what I had before, actually, maybe I should print that. I should print what I had before and after. So this is my before and after, right? And before that, I had one list where some of the objects are simple aggregation metric and they would just return a string. And some of them are multi total last X days and they would return a list. So what I'm doing, I'm flattening this, and now all of the objects that I have here, I'm basically taking this multi last total last X days, and I'm unpacking it into each and every one of the elements. So you see that this list is a little bit longer because I have multiple values in it and I'm just expanding it. Now, all of these things are now of the same type of simple aggregation metric or inherit of simple aggregation metric. So on each one of them, if I now call the get metric definition function, I'll get a string, which is great. So now I can go back and just do the same thing I did here, which is called the get metric definition function for all of them for get metrics, for all metrics. Let's get rid of those. Of this one. and execute. So you can see that I can get exactly the same result. The difference between these two is that this one is just one line of code that's generating this, which is great. Let me get rid of all of those. We don't need them anymore. So now it's back to being nice and clean and tidy. I'll show another nice pattern that is very common in our work and can be followed, which is bucketing, right? And I can basically do count by buckets. And in this case, I have an expression, bucketing column, and bucketing value. My function is going to be count. My expression is going to be case when bucketing value, sorry, bucketing column equals to bucketing value, then expression, else no. Actually, if I'm being pretty honest, I probably don't need that even. Do I? Yeah, I'll use that. So my bucketing columns equals bucketing column, my bucketing value equals bucketing value, and I have my expression, and my alias is going to be num expression bucketing value. Num expression, num transactions, bucketing column, bucketing value. So let me show you one example of that. Let's say that I want to count the transaction ID, transactions over from country for US. So I just want to have a count of how many transactions we have in the US. Let's go ahead and execute. And you see that we have a count case when from country equals US. I need to add quotes. Then transactions else null, non-transactions from country US. Let me just change this to 1 and add quotes. Just 1 second. Sorry, wrong place. Quotes. Okay, so when from country equals US, then 1 else null, num transactions from country US. Obviously, I can repeat exactly the same thing I did earlier with multi last X days. I can create a similar thing, which will follow a similar pattern, and that would be multi count buckets. And in my case, I'm going to create a count buckets for, so I have my expression, bucketing column and bucketing values. And I'm going to count buckets for that same expression, bucketing column and bucketing value for bucketing value in bucketing values. So I'm just wiring it exactly in the same way I did before. And now if I go ahead and I do a multi-count buckets, I can have as many countries as I want. So let's have the US, UK, Sweden, Norway, Denmark, Germany, Austria, Switzerland, France. That should be enough. Bucketing. Okay, which line? 135. Yep. So now I have my number of transactions from country US, UK, etc., etc. I can obviously have the same thing for to country. So I'm just showing you how I'm starting to enhance my query with one line of code, which will basically give me a lot of value. And the ratio of lines of code and output that you get is now becoming quite significant. And this is pretty cool because that's becoming a very decent aggregation table that you might have in your warehouse. And the way to create that or the way to produce that is just only probably less than 10 lines of code here in total. The last thing I'm going to show you is count by ranges, which is again the same concept really. I'll just show you. Sorry, so in this case, what I'll do is I'll have ranges and basically just Boolean flags saying, has that value, yes or no? So range flags. So in this case, what do I need? I need a bucketing column, bucketing value, and the expression. And in this case, what I'm going to do is max case when the bucketing column is greater or equal to the bucketing value, then 1 else 0. I don't really need the expression. I'll just use that for the title as I did before. And then has transactions value greater or equal to, and then the bucketing value. Let's keep it for clarity. GTE flag. So let me show you how that works. So in that case, I want to know if I have a transaction where the amount USD transactions where the amount USD is greater than or equal to 100. And what that will do is it will generate a flag basically, which says has transactions with amount USD greater or equal to 100. Now, same thing, I can just create multi of them. And now they're probably, again, this is becoming very nasty because all of these multi-classes are becoming very similar. So there's a nice way probably of packaging them and making them work in the same way. So I don't need to repeat that. Maybe they can all inherit from the same thing. And what I'll do is I'll just do a multi-range greater or equal to flag, which again gets an expression, bucketing column and bucketing values. I'm going to create a range greater or equal to flags with the bucketing column and bucketing value. So again, it's becoming a little bit cumbersome, but that's okay. Bucketing value, in bucketing values. I hope people are still following, and I can just replace that with multi-range greater or equal to flag of 100, 200, 500, 1000, 5000, 10,000. And if that works, that should give me multiple flags of whether or not that sender or that user had a transaction with amount greater than any of these values. So very, very simple, very easy. And just to show you how powerful that is, again, you see that there's very few lines of code here. I can just go ahead and now I said that I might have a daily aggregation, daily payments aggregation, which will be daily payments aggregation. My dimension in that case is going to be transaction ID, transaction date, fact payment. I might have similar definitions and then daily payments aggregation. And so you see that very easily I can create a lot of, I can basically create all of my or generate my queries based on configuration. They follow similar templates. They're very consistent in how they work. all of these metrics can be tested. So you can create lots of tests to protect yourself from making mistakes and breaking something. It's very easy when you have very long SQLs and you need to maintain long SQLs to make a mistake and break something, and then it's becoming a mess. So it's very, very easy to test every single element here, which is great. Yeah, and that's pretty much it, really. So let me stop sharing now. I don't know if Dave is still here.
Definitely still here.